All right, so in section 6.5, what we need to do to begin with is to understand that we're going to be solving these problems that involve square roots and other radicals under these two assumptions that I have highlighted in yellow for you. Okay, so the first thing is we're going to assume all radicals and expressions with rational exponents represent real numbers. So that means we're not talking about imaginary or complex numbers. The second one is that when solving a square root equation, may result in an extraneous solution because we are squaring each side of an equation, so we need to check our solutions. An extraneous solution occurs when we lose equivalence from one line of algebra to the next through no fault of our own. It just happens to represent a different meaning, and we lose equivalence between the left and right side of the equation. I'll give you an example of that later, but these are the two assumptions we're going to be operating under. Everybody cool with that part? So today is all about us doing a bunch of problems together, and I've labeled them out as easy, medium, and hard. Okay, so we'll start with the easy ones right now. Okay, the easy ones go something like this. Let's solve 3 plus the square root of 2x minus 3 is equal to 8. All right. What do you think that we should do first? What's your gut instinct? What's your reaction? Yeah, Nick, what do you think? Yeah, you got it. Let's get this part by itself, right? The part with the radical, let's get that part by itself, okay? So, yeah, we're going to do what it says. So, we're going to have the square root of 2x minus 3 is going to be 8 minus 3 is 5, right? Now, what do we do? Yes, sir?
Is this possible?
Yeah. What do we do now? Yeah.
Square root each side.
You got it. We're going to actually not square root each side, but we're actually going to square each side, right? So, on the left, we get this. We get 2x minus 3 is now 25, right? Okay. We're squaring both sides of an equation, so we should check for extraneous solutions at the end, even though we're only going to have one for this one, but we're going to see that it's right. Okay, so that means that 2x has to be, 28, right? So x must be 14. Everybody get that with me? Okay, so how do we check this? Well, we do exactly what we think we do. If I can spell that check right, there we go. We simply plug it back in. So we have 3 plus a square root of 2 times 14 is 28 minus 3. Is that the same thing as 8? Yeah, because we're going to get 3 plus the square root of 25. Is that equal to 8? Yeah, because 3 plus the principal square root of 25 is 5. So, yep, we're getting 8 equals 8. Life is good. That's actually an 8. Okay, here's a medium example. We're trying to solve 3 times x plus 1 to the 2/3 is equal to 12. Okay? Anybody got a really good idea we could do first? Remember, we want to isolate the part of the equation that has a radical or a exponent. Yes? Yeah, let's do that first, right? That's a great first move. Let's divide by 3 on both sides, right? Boom. So that's going to give us x plus 1 to the 2/3 is going to be a 4. You guys cool with that part? Okay, now who's got a really good idea here? This is the crucial part of this particular problem. Yeah, Juliana. Yeah, absolutely. You did it perfectly. Let's raise, you mean raise each one to that? Yeah, raise each side to the 3/2 power. What does that do for us on the left-hand side? Yeah, you'll notice, what do we do when we raise a power to a power? What do we get? We get 1, right? Okay, good. So this is good. So over here, now we have x plus 1 is now equal to, this is going to be the square root of what?
64.
Square root of 64. Now, we are raising each side to a squared power, right? A square root of a number cubed. So we have to consider plus or minus in this case, because I have a square root in front of it. Does that make sense to you guys? Okay. So now I have this. I've got x plus 1 is now equal to the square root of 4 cubed. So that's going to be plus or minus 8. So that implies that x has to be either a positive 8 minus 1, which would give us an answer of 7, or x has to be the negative 8 minus 1, which would give us an answer of negative 9. So we want to check both of these. Is everybody on board so far with me still? Okay, good. So let's check. Okay, so we have 2 solutions. We have 7 and we have negative 9. We want to check to make sure each of those works out. So we're going to do, this is 3 times 8 to the 2/3. Is that the same as 12? Well, that's the cube root of 64. The cube root of 64 is 4. 3 times 4 is 12. Yep. 12. Yes, 12 is 12. That checks out. This one will give me 3 times negative 8 to the 2/3. So that's the cube root of 64 again, right? It's because negative 8 squared. So that's going to give me the cube root of 64. So 3 times 4, yep. Check that out. I also get a 12, so they both work. Okay, another medium example for the third box here. We want the 3 times this. So first of all, what should our first move be to get this in a better form for us to work on? Subtract 1 divided by 3. Good. So that's going to give me the 3 times the 5th root of x plus 1 to the 3rd is now equal to 24. Let's divide by 3. Let's divide by 3. So we have the 5th root of and x plus 1 cubed is now equal to, was that 8? Okay. So now we get into a more useful form for ourselves. What should I do now?
You can make it exponential.
Yeah, everybody sees this as x plus 1 to the, what's going to be the root here?
3/5.
X plus 1 to the 3/5. Thank you, I read the wrong spot. To the 3/5, and then good is equal to 8. We still haven't done nothing spectacular there, right?
Oh.
But then we're not times it by 5/3. We're going to raise it to a power of 5/3. That's where my 5 was coming from. Raise both sides to a power of 5/3. So we're having a cube root, right? Okay, so then on the left-hand side, back to my orange, I get this. I get x plus 1. I really don't need the parentheses anymore. Is now equal to the cube root of 8 to the 5th. It's not plus or minus. In this case, it's a cubed root, right? It's a cubed root, not a square root. It's a cube root. So therefore, x plus 1 is now equal to, what is the cube root of 8 to the 5th? Yeah, 32. Therefore, the answer that we're checking is 31.
Wait.
All right, try this one for yourself. 2 times an x plus 3 to the 2/3 is equal to 8. If you need a drink of water, go ahead and go grab one over there. Okay, hopefully you've gotten this far and realized that there are 2 answers, and we're taking a plus or a minus because we are taking a square root of both sides or raising both sides to a 1/2 multiple, right? So the 2 answers that I've come up with are 5 and negative 11. Have you checked both of those?
I got 5.
You should check and realize that these both work out for you, okay? They both work. Okay, ladies and gentlemen, let's talk about one that will have an extraneous solution, okay? So I have the square root of x plus 7 minus 5 is equal to x. So I've got variables on both sides of my equation, so I'm going to get the more complicated radical, x plus 7 by itself. So that's going to give me an x plus 5. Now if I want to get rid of that radical, I'm going to raise both sides to a squared power, alright? So in doing so, by raising both sides to a power of 2, there is a possibility of losing equivalence on left and right sides from the line above it. That's why an extraneous solution occurs. So what we're going to do, we get x plus 7 is now equal to, don't forget how to square out a binomial, x squared plus 10x plus 25. Okay? Don't forget how to square that out. If you forget, then you just absolutely multiply it out, use FOIL or a box or whatever you want to use. Okay, so now, if I get 0 on this side, 0 is going to give me, I still have x squared, 10x minus x is a 9x, and 25 minus 7 is a positive 18. Okay? So we end up with a quadratic, right? So I get this, so I have 0 is now equal to, can we factor this quadratic? And some of you already see it, which is great. And the answer would, of course, be 3 and 6, and everything's positive. So now I have a factored quadratic. And what property am I going to use right now, everybody? What property is this called? No, the zero product property, right? The zero product property. I am multiplying 2 numbers that equal 0. One of them must be 0. So this tells me that x is equal to negative 3 or I get that x is equal to negative 6. Now, I've squared both sides of an equation, and one of the sides of my equation that I squared had a variable in it. So this is a very good clue in order for us to check extraneous solutions. So there are two of them that we need to check right here. So here's the setup that we need to actually check to see. Alright, let's do this part together. On the left-hand side, I get the square root of, what is this? 4 minus 5, does that equal negative 3? Yes, because the principal square root of negative 4 is 2. 2 minus 5 is the same thing as negative 3, so negative 3 equals negative 3. Okay. Then, on this one, I get the square root of 1 minus 5 equals negative 6. Well, 1 minus 5 does not equal negative 6, because negative 4 doesn't equal negative 6. So therefore, it tells you that negative 6 is the extraneous solution. The only one that would work is x equals negative 3. Okay, hard, challenging example. Here we go. The square root of 2x plus 1 minus the square root of x is equal to 1. Whew. Okay, so here we go. Let's get the complicated radical by itself. So I'm going to have the square root of 2x plus 1 is going to be equal to 1 plus the square root of x. So I move that square root of x to the right-hand side. Is it okay with that part? Okay, then I am going to want to square both sides. I'm going to square both sides. On the left-hand side of my equation, I'm just going to get 2x plus 1. On the right-hand side, I get, don't forget how to square a binomial. It's 1 squared is 1, plus 2 times the product of the two numbers multiplied together, so 2 radical x, plus the square root of x squared is just x. Everybody okay with that part so far? Okay. Then, moving right along here, I can see the 1's cancel out, right? So the 1's go away on either side of the equation. So then, and I have 2x over here, and I have 1x over here. So what am I left with?
2.
I'm left with,
X equals 2 radical.
yeah, x is equal to 2 radical x. Okay. Now what can I do? I cannot square root it. I can square both sides of my equation, right? Square both sides of my equation. So x squared is equal to 4x. You see that? Because 2 squared is 4. Square root of x squared is x. So moving along. So x squared minus 4x is 0. Factor in x. That will leave me x minus 4 is 0. What property am I going to use right now, everybody? The zero product property. So either x is 0 or x minus 4 is 0. So x is equal to 4. So I've got two solutions here. Okay, right now you guys tell me which one of them work. Either the 0, the 4, or both. You guys check it out yourself.
They both work.
Yes, you should realize that when you check that both of these also work as well.